Welcome to our discussion of College Board Practice Test 1, Section 4. Let's go ahead and get started. In this question, we're talking about John going different speeds in his training program. Where is his target heart rate strictly increasing, then strictly decreasing? So we're talking about rate of change, and a rate of change can be increasing or decreasing. Rate of change is slope. And the place where we see that off the top of my head is just right here where it's increasing and then immediately decreasing after. And so that looks like it's from 40 minutes to 60 minutes. And so the answer to number 1 is B. Now we're going to question 2. Y equals kx, k is a constant. Well, if y is 24 when x is 6, the idea that k is a constant means that once we find it, it won't change. So y equals kx, but in that, y is 24 when x is 6, and we can do that setup there to solve for k, divide both sides by 6, and k equals 4. So k is a constant, it's not going to change, so we can rewrite it as y equals 4x. For the next situation, they're saying, what's the value of y when x is 5? So we can just plug in x is 5, and we get y is 20. What's the value of y when x is 5? Y is 20, and the answer to number 2 is C. Going over to number 3 now. In the figure above, L and M are parallel, S and T are parallel. Okay, so if the lines are parallel, there's 2 ways to see this. One way is to say that, well, first of all, these two are vertical angles, so by default, they're going to be congruent to each other. But that same fingerprint for 2 pairs of parallel lines, you'll have the same fingerprint at every intersection. And I have this purple angle equal to this purple angle, and that fingerprint also exists at any of these. So for every one of these intersections, we have the same fingerprint, where there's the same angle in the upper left and lower right, and also the same other angle in the lower left and upper right. So with that same fingerprint, it's easy to say that if angle 1 is 35, then this other purple angle must also be 35. So you have 35 here and 35 here. Now, in terms of the pairing of one blue and one purple angle, those are just linear pairs. If this is 35, these 2 angles here have to add to 180. So this one here has to be 145. And so if this is 145, that goes for any of the blue angles. So when we look at angle 2, it's one of the blue ones, so it's 145. So when you have 2 pairs of parallel lines, that creates kind of like a number symbol there. You can look at the fingerprint of every intersection, which should be identical. Another note to make about parallel lines is that for parallel lines, we're looking for C's and Z's. So what we mean by that is, if I have the letter C or a backwards letter C, in that situation, the 2 inner angles there, angle 1 and angle 2, or angle 3 and angle 4, the measure of angle 1 plus the measure of angle 2 equals 180. Or the measure of angle 3 plus the measure of angle 4 also equals 180. So that's if you have a C shape. Now, if you have a Z shape, so we'll draw ourselves some more parallel lines to be able to illustrate that. The Z shape would look something like this. So you have the letter Z right there, or the backwards letter Z right here. With the Z shape, the angles will be equal. So angle 5 has to be equal to angle 6, or angle 7 has to be equal to angle 8. So the inner angles of a Z shape, so angle 5 equals angle 6, angle 7 equals angle 8. So for C's, we have 2 supplementary angles, and for Z's, we have 2 congruent angles. So that lesson there will come up more frequently than the idea of the fingerprint, because it's more rare to have 2 pairs of parallel lines all intersecting in that number number sign type of manner. So let's go on to number 4. The answer to number 3 was D. And number 4 here says 16 plus 4x is 10 more than 14. So let's just take that quite literally. 16 plus 4x is 10 more than 14. One of the beautiful things about math is that with a few exceptions, the math matches the verbal statement. So now we're just solving. And we're solving for 8x, which means it would be easier for us to find 8x directly than to find x and then multiply it by 8. So let's go ahead and combine like terms on the right. So we get 24 here, take away 16 from both sides, and you get 4x equals 8. On a lot of these questions, 8 will be an answer or 2 will be an answer because x is 2. So it would be really easy to lose your train of thought for a moment and then just pick 2, right? But we don't want x, we want 8x. So let's go ahead and just multiply both sides by 2. That'll give us 8x on the left, which is what we want, and 16 on the right. So the answer to number 4 is C. Going over to number 5. We're looking in number 5 for a negative association, also sometimes called a negative correlation. And so a positive correlation would just be something like that, and a negative correlation would be something like that. So which of these looks like a negative association or a negative correlation? And that would be D. It looks exactly like the negative correlation that we drew on our own here. So the answer to number 5 is D. Looking over to number 6 now. A hospital stores 1 type of medicine in 2 decagram containers. How many 1 milligram doses are there in 2 decagram container? So a lot of purposeful confusion, but we're talking about 2 decagrams. And the chart says that 1 decagram is equal to 10 grams. Now, when we're doing unit conversions, this is chemistry style unit conversion here, or in some schools, it's called dimensional analysis. But you're looking for multiples of the number 1, because the number 1 is a fraction that would have the same number on the top and on the bottom, or the same variable on the top or on the bottom, or set of variables, or the same units on the top and the bottom. So for instance, 3 feet is the same as 1 yard. So since they're the same as each other, that's just the number 1. And you're also trying to set up, if you have a unit on the top, you want the corresponding unit on the bottom. So we could have said 10 grams over 1 decagram or 1 decagram over 10 grams, but we're choosing to put the decagrams on the bottom because it's going to cancel. Now we've got grams, but we're looking for milligrams. So we want grams on the bottom to cancel against this grams on the top. So what's the conversion between milligrams and grams? 1,000 milligrams is the same as 1 gram. So now we have what we want, which is these grams canceling each other. This whole fraction here is equal to the number 1 because 1,000 milligrams is equal to 1 gram. So all we did was multiply. So all we did was multiply by the number 1 once and twice. So we haven't changed anything, but we've dramatically altered the appearance. So we have 2 times 10 times 1,000. So we have a 2 with 1, 2, 3, 4 zeros. So a 2 with 4 zeros on the top. And we just have the number 1 on the bottom, and the only remaining unit is milligrams, which they were asking us for. So we know how many milligrams there are. And 1 milligram, I guess, could be called a 1 milligram dose. So the answer for number 6 is D. Going to number 7 now. The number of rooftops with solar panel installations in 5 cities is shown in the graph above. If the total number of installations is 27,500, what's an appropriate label for the vertical axis on the graph? So what adds up to 27,500 here? Well, whatever the axis is called, There's 9 of them here, 5 of them here, 6, 4, and 3.5. So 9 plus 5 is 14, plus 6 is 20, plus 4 is 24, plus 3.5 is 27.5. So all of these numbers here add up to 27.5. And so 27,500. So it's 27.5 thousands. And what did we have 27.5 thousands of? Installations. So what's the unit here? It's the number of thousands of installations, which is choice C for number 7. Going to number 8 now. For what value of n is this expression equal to 0? Okay, so what's going on here? We're kind of being asked about the definition of an absolute value. An absolute value, if a number is positive or 0, does nothing. And if a number is negative, it makes it positive. So it either does nothing to a number or makes it positive. So here we have an absolute value. I'm not worried about the idea that there's an n-1 inside the absolute value yet. But the idea is that entire blue bubble there is going to either be positive, or if it was already positive or 0, nothing would be done to it. So the minimum value of this entire blue thing here, the minimum value is 0. Because if it were positive, it would be left alone. If it were 0, then nothing would be done to it. So this whole n-1 can equal 0. So now if n-1 equals 0 as the minimum, then the smallest value for n is 1. So for what value of n is the whole expression equal to 0? Well, we just said that the smallest thing you could ever have in there is the blue thing equaling to 0. So n-1 equals 0 if n equals 1. So this whole blue thing is 0 plus 1, which is this piece right here. So if the smallest possible thing we could have is 0 plus 1 for the whole thing, that's our smallest value is 1. Then how could we make it equal to 0 if the smallest possible value for it is 1? So the answer to number 8 is D. There's no such value of n that can do this. Going over to number 9 now. Which of the following expresses the air temperature in terms of the speed? So the air temperature is T. And so they're saying express T. So they're just asking us to solve for T here. So what's the first thing we could do to solve for T? We could take away 1052 from both sides. So A minus 1052 equals 1.08 T. And now we just need to get T by itself. So we can divide by 1.08. And we'll get T equals A minus 1052 over 1.08. So the answer to number 9 is A. Let's go ahead and just bring this image next to question 10 so we can see it better. Apologies for the delay here, guys. So question number 10. At which of the following air temperatures will the speed of a sound wave be closest to 1,000 feet per second? So the speed of a sound wave is the whole thing they're talking about. It's A. and we need A to be 1,000. So in the equation, that would look like 1,000, which is A, equals everything else that we had. So now we can take away 1,052 from both sides and divide both sides by 1.08. So negative 52 divided by 1.08 is negative 48.148 on my calculator. So the closest that we have, because they asked for the closest, is B for boy on number 10. Now we're going over to number 11, and we'll bring our question along with us so that we can have it looking a little more easily visible here. Actually, we'll put this here for when we get to question 12. But for question 11, we have every component of the question right there where we can see it. And which of the following is not a solution of the inequality? So if we know what is a solution, then we'll know what's not a solution. So let's go ahead and just solve the inequality. 3x minus 5 greater than or equal to 4x minus 3. Take away 3x from both sides, and you'll have negative 5 greater than or equal to x minus 3. Add 3 to both sides, and you'll have negative 2 here. Flip it around because we want the variable first, and x is less than or equal to negative 2. So if x is less than or equal to negative 2, which of these numbers is not less than or equal to negative 2? It might be helpful to kind of visualize this. So I'll have 0 here, positive 2 here, and negative 2 here. And less than or equal to is a solid dot, and we're going in the lesser direction. So that right there is x is less than or equal to negative 2. And which of these is not part of that? Well, negative 3 would be here, negative 5 would be here, so they're okay. But negative 1 is outside of that solution. So the one that's not possible for number 11 is A. Now we're going to 12. And we have the, let's see, number 12 is unrelated. It only actually didn't even involve for 11. Okay, so for number 12, we'll delete some of this stuff that's covering up our information here. Okay, number 12. A histogram is a frequency chart, and they tend to confuse people a whole lot. So we need to know that there are 2 apples with 3 seeds, 4 apples with 5 seeds, 1 with 6, 2 with 7, and 3 with 9. Maybe part of the deceptiveness of this problem is the idea of making the numbers so similar. So there are 2 with 3 and 4 with 5, and all the numbers are the same numbers. So of course, as a test writer, if I made these numbers 53, 54, 55, or something unrelated, it would be easier to make sense of. But just pay close attention to the frequency. It seems like the easiest thing ever, yet almost everyone stumbles on it. If we want the average number of seeds per apple, the average, the mean, is the sum over the number of items. So the sums now, if I have 2 that have 3 in them, then the sum is 2 times 3. I have 4 that have 5 in them, 1 that has 6, 2 that has 7, and 3 that has 9. And there are 12 apples altogether. So the sum is all of these things multiplied together and added, and the number is 12. So the sum over the number is going to be just all this calculated out: 6 plus 20 plus 6 plus 14 plus 27, all divided by 12. So you have 73 on the top, 12 on the bottom. And the answer is 6.083 repeated. So which is closest to that is the number 6 on number 12. Okay, going over to number 13 now. Going over to number 13, we're saying 19% of all the survey respondents, and which of these would account for 19%? So here's the actual data in green, and the stuff in purple here are the totals. So we don't want to get distracted by the difference between those two. But what would be 19% of all the respondents? So first of all, we're taking a percent of all the respondents, and conditional probability and conditional fractions are a common thing on the SAT. Those would be the situations where we're just taking from part of the survey. So it would sound like, what percent of the students are taking Algebra 1 if we're only considering from the female students? That would be the conditional idea. But here it's easier because it's all. So a percent is a part over the whole. So if we're taking it out of all of them, then the number on the bottom is just going to be 310 no matter what. So now what number over 310 is going to give us 19%? And we can pretty much try all the numbers here. So 35, I'm just doing this on my calculator, 35 divided by 310 is 0.11. 53 divided by 310 is 0.17. 62 divided by 310 is 0.2. So that's the closest one so far. And actually, if 62 is close, then 59 will be closer, right? So 59 divided by 310 is 0.19. So 59.19 is 19%. So what group are we talking about? We're talking about the males taking geometry. So the answer to number 13 is C. Going over to number 14 now. We have a random sample. We have an outlier measurement of 24. That's an error. Which will change the most if the 24-inch measurement is removed from the data? So we have a bunch of pieces of data. So this is not to scale. It's not to match up with the number of pieces of data that we have, but we have a whole lot. And then the number 24 would have been the biggest one out of the bunch. So what's the next biggest number besides 24 in this situation is the number 16. 1, 2, 3, 4, 5, 6, 7 times 3 is 21. 14, 15, 16, 17, 18, 19, 20, 21. All right, I just changed the number of symbols in here. They're not zeros, but they're empty spaces in the way I'm doing this. So we have 21 pieces of data. Now it is to scale. And the two biggest ones are 16 and 24. So the smallest data point is the number 8 right here. So from 8 to 24 is the range. The range is the distance between the highest and the lowest values, right? So the range when we started, let's call it range 1, is 24 minus 8, which is 16. The range 2, after we remove the outlier, is 16 minus 8. It becomes 8. So that number is going to change quite a bit. The median won't change a whole lot because if I just cross off the 24, the middle number is still close to the same middle number at least. The mean is only going to change a little bit because the average is the sum over the number. And so we're changing a tiny piece of that. And we can kind of make the assumption that it's not going to change as much as the range. The range changed by 8. And that's a very big in comparison to these numbers that we have. I don't know, if you remove the 24, I would imagine the average might go from like 12 to 11.5 or something like that. So the range is changing quite a bit. And the answer number 14 is C. Now we've got number 15. What does the C-intercept in the graph represent? So the C-intercept is right here. Generally, when you have a linear, and we talk about this a lot, it's a y equals mx plus b. your B is your starting value, and your M is the rate of how much it changes as it goes, which is going to give you the tilt. And it could be positive, which would make it go uphill, or negative, which makes it go downhill. So what is the y-intercept of any graph? It's the starting value when x is 0. Starting value when x is 0. In our situation, the x-axis is the time, when the time is 0. And the values on the y-axis are the cost. So substituting in time and cost, the c-intercept is the cost when the time is 0. So which answer says that? The initial cost of renting the boat, the cost when the time was equal to 0. So the answer number 15 is A. Now we're going over to 16. What's the relationship between H and C? The relationship is getting back to this idea of the y equals mx plus b. What is our slope and what's our y-intercept? The y-intercept is 5, and your slope is your change in y over change in x. If you're given the graph, I would prefer you do that over using the slope formula, but the change in y is a change in 3, and the change in x is a change in 1. So what change in y over change in x is 3 over 1, so the slope is 3. Y equals 3x plus 5, or in terms of the letters they used, c equals 3h plus 5. So the answer to 16 is going to be C. But the one important thing to note is the deceptiveness in the fact that on the y-axis, every hash mark symbolized 1. But on the x-axis, every 4 hash marks symbolized 1. So therefore, it could be really easy to say the slope is 3 over 4, which is what they were trying to bait us into for answer choice B. So now we're going over to number 17. Not part of the same scenario. For what value of x is f of x at its minimum? So when we're talking about min and maxes, the min or max of a function is going to be the y value. The y value, the actual height, is the max or the min, the maximum or the minimum value. But if I tell you where to find the max and min, then that means I'm referring to the x value. So a little subtlety in the wordings. So for what value of x is it at its minimum? They're saying this piece right here. Where can we find the max and min? So now look how deceptive. The minimum itself is -2. That's the y value, but the question is not asking us that. It's saying at what value of x do we find that? Well, we find that at x equals -3. So while a lot of people maybe rushing through here would have picked C for number 17, the answer is actually B. Now we're going over to 18. So 18 seems like a tough question, but whenever you're given a point in a situation, go ahead and plug it in. So in other words, why are they giving us the point if not to do something with it, right? So let's plug in 0, 0. So in the first equation, 0 less than -0 plus a, 0 less than a when it simplifies. And in the bottom equation, 0 greater than 0 plus b, taking away the 0 on the right, that's 0 greater than b. So flipping them around so they're easier to read, a is greater than 0 and b is less than 0. So let's just imagine that on a number line. A has to be somewhere in this green region because it's greater than 0, and B has to be somewhere in this blue region because it's less than 0. So A is definitely greater than B. And the answer to number 18 is A. Let's look over at number 19 now. 19 is your classic system of equations, of linear equations, word problem. It's our system of linear equations word problem. So in systems of equations, we're always or usually dealing with the price times the quantity. And the price is not always money. The price is just some number that gets assigned to each item in terms of this way of thinking about it. But in the systems of equations word problem here, we are looking for the price and the quantity of each item. In this case, salads and drinks. So right here, we're being given the price of every salad. Right here, we're being given the price of every drink. So with this process, we can say to ourselves, X and Y must be the quantity of each. And this little thought process is surprisingly important. It's the X is the number of salads and Y is the number of drinks. So if it isn't just obvious to you how to set it up, going through the process of thinking about the price and quantity of each is going to kind of allow you to figure out what sentences to write. So there's a total of 209 salads and drinks. And if X is the number of salads and Y is the number of drinks, then 209 is the total number of salads and drinks. It's X plus Y. And then we'll have our usual price times quantity statement, which is something equals 836.50 here. And that's going to be the price of a salad. So 650 times the number of salads, and the price of a drink times the number of drinks. So 6.5x plus 2y equals that. Now it's just a system of equations question of how to solve. So for me personally, I might multiply the top equation by -2. -2x minus 2y equals -418. And now add these two equations to one another. 6.5 minus 4 is 4.5. And 836.50 minus 418 is 418.50. And divide both sides by 4.5. And you get X is 93. And X was the number of salads. And that's what they're asking us for. And it's 93. So the answer to number 19 is B. I can't stress enough here that the writing out of what you're talking about is the most important part of a question like this, so you can approach it with a clear mind. Going over to number 20. Alma bought a laptop at a store. They gave a 20% discount off its original price. The total amount she paid was P, including an 8% sales tax. So if you're going fast here and you haven't done a lot of these, they're trying to bait us into saying that the price was P with a 20% discount and an 8% tax, and then solve it that way. But that would be exactly backwards. Now, why 0.8 and why 1.08? We'll talk about that in 1 second. But the real question is saying that there was some price, which was the original price. And so we have that price, and we had a 20% discount. So what do we multiply by? It's going to be 0.8, but I'll explain why. With percents, you always start at 100%. From there, if we lost 20%, it would be 80%. And if we gained 20%, it would be 120%. And both of these are going to be done in decimal form, so 0.80 and 1.2. So a 20% discount is a loss of 20% from 100, so it's 0.80. And an 8% sales tax is the same idea. With percents, you start at 100. If I lost 8%, it would take me to 92%. Or if I gain 8%, it would take me to 108%. And we use both of them in decimal form. So we have the 8% sales tax right here. And that resulted in paying a price of P. So right now we told the story accurately. If we had told the story this way, it would be the exact opposite order of what we were supposed to do. So the original price is X, and now we have to just solve for that. So we're going to divide by 0.80 and divide by 1.08 on both sides. And so these cancel, and X is equal to that right there. P over 0.8 and 1.08. So the answer to number 20 is D. And now we're going over to number 21. Okay, so cutting through the really long word problem here. The question at the end says, if a person is chosen at random from those who recalled at least one dream. So this is our conditional probability or conditional fractions. And if I were taking a percent or a probability based off the whole group has 200 in it, so the denominator would be 200. But for conditional probability, they're telling us it's only from the ones who recalled at least one dream. So that includes 1 to 4 and 5 or more. So that includes these pieces of data here, the 28, the 57, the 11, and the 68. So these are the 4 categories of people, not including the totals, because we don't want to count the same numbers twice. But these are the categories of people that remembered at least one dream, because they remembered 1 to 4 dreams or 5 or more dreams right here. So we're going to have in our denominator 28 plus 11 plus 57 plus 68, those 4 numbers. And from that number, what's the probability that they belong to group Y? Well, which of these belong to group Y? These two did, 11 and 68. So once again, the idea of the conditional probability or conditional fractions is the idea that we have a smaller group of data that we're choosing from. And so it's just the perfect storm of an SAT problem, because it's actually easier because we're dealing with less data, but it's just a little confusing because a lot of people are not familiar with this. So let's just go ahead and solve it out. We get 79 on the top, and on the bottom, we get 164, and that matches choice C for number 21. Going over to 22 now. So 22 is saying the average rate of change for the agriculture natural resources from 28 to 2010. So we've got agriculture natural resources from 2008 to 2010, takes us from this number to this number. But the really critical part of this question is that all of this is in thousands of dollars. So what does that mean? That means that each of these numbers is describing a number of thousands. So for instance, if I had the number 1 somewhere in this chart, then that would signify 1,000, and I would add 3 zeros to it. So every one of these numbers has 3 more zeros to it, 3 more decimal places than what we're imagining. So we can do that right here. We can add 3 more zeros. And when we're dealing with the rate of change now, well, slope is rate of change, is your change in Y over change in X. But because we have the actual data here, then we can maybe use the slope formula, Y2 minus Y1 over X2 minus X1. And what are our points? Our points are the idea that when we were in 2008, we had 358 million, I won't use a comma, you can see why, 358,904,000. And when we're in 2010, we had the number 488,106,000. And those are our points. Those are our x1, y1, x2, y2. And so when we plug into the slope formula, y2 minus y1, it might be a little strenuous to write this out. I'll just do it on the calculator. So 488,106,000 minus 358,904,000 comes out to this number right here, which I'm just taking from my calculator. And now I'll go ahead and put the commas. And the denominator is x2 minus x1. So 2010 minus 2008, which is just 2. So basically, we're taking that number and dividing by 2. And we get 64,601,000, which is this letter B right here. And the answer to 22 is B. Now moving on to 23. Of the following, which program's ratio of its 2007 budget to 2010 budget is closest to the human resources program's ratio of 2007 to 2010? So what's HR's ratio? HR is right here, human resources, and the ratio of 2007 to 2010 for HR. Remember, each of these numbers has 3 more zeros than we can see because it's in thousands. So the ratio of 2007 to 2010 is a ratio of 4,051,050,000. Maybe this is a good moment to remind you that we recommend using a TI-84 calculator or similar graphing calculator as long as it's allowed on the SAT, because with these giant numbers, you're going to want a calculator that can handle that. So that number divided by 5,921,379,000. And what do we get when we divide those out? Generally, it's looking like 4 divided by 5.9. And that's going to be something in the range of 0.67 or 0.68. So dividing that out gives us a number in the range of 0.67. And which other one, 2007 to 2010, is in, it has the same ratio of 0.67. So for, well, okay, now my shortcut for doing this, if you noticed, was I just divided 4 over 5.9 on my calculator. So notice the nature of that fraction. It's something slightly larger over something slightly bigger, actually closer to 4 over 6, which would be 0.6 repeated, right? So if we compare these sets of numbers, we're looking for the one that has like a 4 to 6 relationship, slightly smaller on the top, slightly bigger on the bottom. So for agricultural natural resources, this number compared to this, I could see that as 3.7 over 4.88 or 4.9. That looks good. So that comes out to 0.77, just doing it quickly. So 0.77. Education, since the number places match up, I could see that as 2.1 over 3.0. So 2 over 3, which is 0.66. So education looks good for this one. Highways and transportation, I could see this as 1.4 over 1.7, which is 0.82. And public safety, as long as the number places match up, we can see this as 2.6 over 4.6, or 26 over 46, which is 0.57. So the one that matches the most closely is education, which is B for number 23. So nice little shortcut there for avoiding all the millions and billions digits that were in this problem. So let's go over to question 24 now. we need the equation of a circle with a center of 0, 4, and a radius of 4/3 and 5. So first of all, you need to know the equation of the circle by heart in order to do your best on an SAT. So that's our equation of a circle. And the center of that equation is the h comma k. So h minus 0 squared plus y minus 4 squared equals r squared. Simplify that a little. So we already know that this can't be right and this can't be right because we need y minus 4. And then for the other point, if it's a point on the circle, and this is the equation of the circle, we can plug that in as the xy combination. So x is 4/3 and y is 5, and just solve from there. So 4/3 squared plus 5 minus 4 squared equals r squared. Right, so we have 4/3 squared is 16/9, 5 minus 4 is 1, 1 squared is 1. So 16/9 plus 1, and 16/9, well, 1 can be considered 9/9. So 16/9 plus 9/9 is going to give us 25/9, and that's r squared. So if 25/9 is r squared, square root of that is 5/3. But with the equation of the circle, we're actually looking not for r, but for r squared. So 25/9 is r squared. And now we know that out of these two, which are our last two answer choices standing, that we want 25/9 right there. So the answer to number 24 is A. Now we've got number 25. This is an equation for the height based on the number of seconds after being launched vertically upward. And then the question says, after how many seconds will it hit the ground? Well, hitting the ground, what does that mean for height? That means our h is equal to 0. So we'll write that in, h equals 0. This is a quadratic situation because it has like an x squared, or in this case, t squared. And it's a 2-term quadratic. And you need to know, as a rule that you have memorized, that when you're dealing with a 2-term quadratic, you should pretty much always use the GCF followed by the zero product rule. I'll show you what that means. So the GCF, the greatest common factor for the two numbers that we have here, we can just say is t, because we have decimals, so there's no integer that divides both of them, right? So if we just take out a t and factor that out, so in other words, we're dividing both of these terms by t, it leaves us with negative 4.9 t plus 25. The way we can verify that is if you distribute it back out, you'll get negative 4.9 t squared plus 25t. But now we have the zero product rule, which says these two things multiply to 0, so we can set each one equal to 0. So we're taking both of those expressions and setting them equal to 0. And the first one is 0, which makes sense because this was launched at 0 seconds. So the first time, we're looking at an upside down parabola. It's a quadratic with a negative in the front. It was launched at 0 seconds, and then it comes down at some point as well. So we can just solve the equation on the right. Negative 4.9 t equals negative 25, and 25 divided by 4.9 is 5.1. So the answer for that side is 5.1. And the closest to that is D on number 25. Now we're going over to number 26. 26 is a surprisingly tricky question. So we want to proceed carefully whenever possible. So just go ahead and write out what you're talking about. So we have type A trees and type B trees, and A produced 20% more. So we refer to this as a comparative grouping when one variable is built off of the other. So A is built off of B. It's 20% more than B. So if B is X, A is 20% more than X. And how do we find 20% more than something? Percents always start at 100. If you add 20%, it takes you to 120%. Taking away 20% takes you to 80%. And then you have them both in decimal form. So adding 20% is 1.2 times what we had before. So once again, A is built off of B. Therefore, B is the X, and A is whatever we're building off of X, which is 1.2 times X, 20% more. And the type A produced 144. So now we have an equation that solves. 1.2x equals 144. Divide both sides by 1.2. And 144 divided by 1.2 is 120. And that's our X. What did type B produce? 120. And the answer for number 26 is B. Number 27 now. 27 is a nice lengthy word problem for us here. And we have a square field measuring 10 by 10. So the whole field is 10 by 10. So the whole field is 100 square meters. Each region has a length of 1 meter on each side. So each region is 1 square meter. And in this chart here, we have 10 students marking off a region. So this whole thing represents 10 regions. So the question is saying, how can we approximate the number of earthworms in the entire field? So 10 regions gave us how many? Let's just add up, 107 plus 147, and all these numbers, 146, 135, 149. So we're adding up all those numbers, and they add up to, so all of these numbers here, just pop them in the calculator, and they added up to 1,471. So if 10 regions is 1,471, then 100 regions is going to be how many? And we can use a proportion to solve that out. Cross multiply, 10x equals 100 times 1,471. So multiply those out and then divide by 10. And we get x equals 14,710, which is closest to 15,000. And so the answer to 27 is C. Going over to number 28 now. The system of inequalities is graphed in the XY plane above for number 28. Which quadrant contains none of the solutions? So if we consider this green one here, that's very similar to the line y equals 2x plus 1. That would have a y-intercept of 1 and a positive slope. It's a solid line because it's greater than or equal to. And because it's the greater than in general, we're going to go ahead and shade above it. Now for the other one, for the blue one, that's similar to the idea of having y equals 1/2 x minus 1. So that would have a negative y-intercept of -1 and a positive slope of 1/2, so up 1/2. So I'm actually going to kind of make it more vertical just so that we see the intersection. But the idea of what we're seeing here is that we're shading above that. So just to be a little careful here so it looks okay, we're shading above the green line, which created this yellow region. And now we're going to shade above the blue line, which is going to create this blue region here. But as we keep shading upward, we see the double shading changes color. So the area that got shaded above both lines is this area right here. And that area, as we can see, it exists in quadrant 1, in quadrant 2, and a little tiny bit of it in quadrant 3. So use a different color there. It exists in quadrant 1, in quadrant 2, and a little bit in quadrant 3. But there's none of that dark green area taking place in quadrant 4, which is right over here. So which quadrant has no solutions? Quadrant 4. So that was number 28. And we've got number 29. There's a little miscellaneous rule that comes up in math that says that if plugging okay, how do we say this? When you plug in a root and you get a remainder, that remainder is going to be the value you get after you divide it. Something along those lines. But we're saying that, P of 3 is the idea that x equals 3. And if x equals 3, and if that were a factor, then that means that x minus 3 is a root. So in terms of factors and roots, this means that if I plug in x equals 3 into a function, it should have been 0 if it were a factor. It's not, because they're not saying P of 3 equals 0 here. They're saying P of 3 equals -2. But let's just say it equals 0 for a second. The definition of that would mean that when x is 0, when x is 3, the function comes out to 0. Or if you divide by x minus 3, you get no remainder. Right? But if you divide by it and the value that comes out is -2, then that means your remainder is -2. So the answer to 29 is D, based on a very obscure rule that, to be honest, we haven't seen in any SAT except for test 1, section 4, question 29. So we'll move through this fairly quickly. Now we're going over to question 30. Which of the following is an equivalent form of an equation of the graph from which the coordinates of vertex A can be identified as constants in the equation? Okay, so we have the vertex A. It looks like it has an x value of 1 and a y value of -15, but we're not 100% sure. But when we're talking about a vertex of a parabola, there's two ways you can get that. You can get that as x equals -b over 2a from the a, b, and c coefficients of the quadratic. Or if you had it in a format where it was easy to see the zeros, formats that look like this, then you would kind of say the x value of the vertex is the average of the zeros. And for both of those situations, when you plug in the x value of the vertex, it'll spit out the y value of the vertex if you plug it back into the equation. So here we can find the x value of the vertex using this by plugging in, by getting -b. Okay, so a for this is 1, b is -2, c is -15, just as far as the three numbers that are coming in front. So -b over 2a is -2 over 2 times 1. So just confirming that the x value of the vertex is 1, because we can kind of obviously see that that's the case. So +2 over 2, which is 1. So that's our x vertex. But then to find the y value of the vertex, you're going to go ahead and plug that back into the function. So the y value of the vertex means that we take the number we just found and we plug it in. So f of 1. And f of 1 is 1 squared minus 2 times 1 minus 15. So 1 minus 2 minus 15 is -16. And that's the y value of our vertex. So the question is saying, where can we see the coordinates of the vertex identified as constants in the equation. So the coordinates are 1 and -16. Which one do we see a 1 and a 16 in general? Would be choice D, and the answer to 30 is D. Moving along to number 31. So 31 is kind of the idea that we refer to as plugging in parameters. And for plugging in parameters, my recommendation is to go ahead and see both sides of it. So if Wyatt can husk at least 12 per hour and at most 18 per hour, then we can kind of figure it out for both. So for instance, I have 72 dozen ears of corn. And in the 12 scenario, he can do in 1 hour, he can do 12 dozen. So notice that the dozens are canceling, and this whole thing is equal to the number 1. That's why we're able to multiply by it, because when you multiply by 1, nothing happens. 72 divided by 12 is 6. So we have 6 hours right there. And let's do it for the 18. We'd have 72 dozen, and we're multiplying it by the idea that in 1 hour, he can do 18 dozen. Once again, the dozens cancel, and 72 divided by 18 is 4. So we have 4 hours right there. So the answer is anything from 4 hours, anything from 4 hours to 6 hours, including 4 and 6. So if on this we just entered in the number 5, we would get the question right. Anything from 4 to 6 or anywhere in between. Going to number 32. So the weight limit is 6,000. A truck has X identical boxes weighing 14 pounds. The weight of the truck and the driver is 4,500. What's the maximum value for X that'll keep everything below the weight limit? So the total limit is 6,000. The truck and the driver is 4,500. Let's go ahead and say pounds. 4,500 pounds plus, and then for the boxes themselves, we have X boxes, and 1 box weighs 14 pounds. So this is kind of like a linear type of equation with a unit conversion in it. And that should all come out to 6,000 pounds. So now canceling units here, we have boxes cancels with boxes. And so that simplified comes out to 4,500. 4,500 plus 14x equals 6,000. And this is going to tell us the number of boxes that's going to give us the exact amount, which means that less boxes would have given us less weight, right? So the maximum possible, it's almost like a false maximum, because we're going to find the exact amount. And of course, the exact amount of something is the maximum amount. More than that would be too much. So take away 4,500 from both sides, and you get 1,500. And X equals 1,500 divided by 14, which is 107.1. So you get 107.1 boxes, and you'd be right at the limit. So the maximum number of whole boxes is 107. 107 for number 32. Going over to number 33 now. Number 33 is hiding. Okay, number 33. According to the line graph above, the number of portable media players sold in 2008 is what fraction of the number sold in 2011? So the number sold in 2008 is right here. The number sold in 2011 is right there. A fraction is a part over a whole. So the part is what was sold in 2008, 100, And the whole is what was sold in 2011, which was 160. So we're dealing with the fraction 100 over 160 divided by 10, divided by 2. And the answer for number 33 is 5/8. Number 34. So we have time slots for programs in 30-minute intervals, 24 hours per day, 30 days, every day out of the week. And we're talking about 30-minute time slots for Tuesday and Wednesday. So Tuesday and Wednesday is 2 days. And 1 day is 24 hours. So once again, unit conversions. And this is equal to the number 1. So we're just multiplying by the number 1. It's a fraction with the same thing on the top and on the bottom. And 1 hour is 60 minutes, by the way. So by that conversion, with the same thing on the top and on the bottom, the hours are going to cancel. And 1 program takes 30 minutes. So now in terms of cancellations, days cancel with days, hours cancel with hours, minutes cancel with minutes, and we're talking about time slots, or what we call programs. So the number of programs is going to be what you get when you multiply 2 times 24 times 60 and then divide by 30. Which comes out to 96. And so the answer to number 34 is 96. Going over to 35. The volume of the silo is 72 pi. The height is 8. In the formula sheet, we know the volume of a cylinder is pi r squared h. So the volume is 72 pi. We don't know the radius, and the height is 8. And everything is in yards, so we can just verify that so we don't have conflicting units. Divide both sides by pi. Divide both sides by 8. Square root of both sides. And the radius is 3, but they're asking us for the diameter. Diameter is twice the radius. So the answer to number 35 will be 6. 36, we're talking about undefined values. And there are 2 things that we need to know are undefined. That would be having a 0 in a denominator or having a negative under a radical. So there's no radical here. So we're looking for zeros in the denominator. So we're looking for what value would make all this stuff, which is what we have in the denominator. What would make all this stuff equal 0? So just expanding this out, this would be like x minus 5 times x minus 5. Right here, you're distributing 4 times x minus 5, so 4x minus 20. So 4 times x and 4 times negative 5 plus 4. And now we need to FOIL out the bottom. So right now we've got first times first, x squared. Outer times outer. Outer times outer. 5 times negative, or negative 5 times x. So negative 5x. Inner times inner is again negative 5x. And last times last, negative 5 times negative 5 is positive 25. With everything else that we already had. So let's combine all our like terms. We have x squared, there's only one x squared. For the x's, we have negative 5x minus 5x plus 4x. So negative 10 plus 4 is negative 6, so minus 6x. And for the numbers themselves, we have 25 minus 20, which is 5, plus 4. So 5 plus 4 is 9. Now we're in a BC factoring situation because we have numbers in the B spot and in the C spot, but we have no number in the A spot. So this is BC factoring. BC factoring says we need two numbers that add to B and multiply to C. So what two numbers add to -6 and multiply to 9? That would be -3 and -3. So x minus 3 squared, x minus 3 times x minus 3 equals 0. And the zero product rule says these two things multiply out to 0, so we set each one equal to 0, but it's the same thing both times. So x minus 3 equals 0, x equals 3. What is the number that creates our undefined value? X equals 3. And we started that by setting the denominator equal to 0 and going through all the solving steps of finding out what x value achieves that. And so the answer to number 36 is 3. So question 37 is going to be asking us about exponential equations. Just a little housekeeping here to prepare for doing question 38 in a moment. Okay, question 37. We have a bank account that has 2% interest compounded annually. So this is an exponential situation. A starting number multiplied by something x number of times. Here, the initial deposit is 100. So the initial deposit is 100. And it's earning 2%. We've talked about this a lot. When you add 2%, it goes to 102%. So percent's always start at 100. Take away 2%, it takes you to 98%. So earning 2% is 102%, which is the same as 1.02. And it happens t number of years. So this is our exponential equation, 100 times 1.02 to the t. And what's the value of x? 1.02, like we said. So this is our equation, and we're going to use it on number 38 as well, probably. So Jessica's friend earns 2.5% interest, and how much more will the friend earn after 10 years? So if it were 2.5% interest, so instead of adding 2 to 100, we're adding 2.5. And in decimal form, that'd be 1.025. Or if we were taking away 2.5, it'd be 90.975. So we have, for Jessica, we have the same thing we had before, 100 times 1.02, and it's to the 10th. So that's Jessica. And for Taishan, it's the same thing, but the thing we're multiplying by is 1.025 now. And that's to the 10th because this is happening 10 times over 10 years. So throwing each of these in our calculators, we get 121.899. And here, we get 128.008. So the question says how much more? So we subtract the bigger number minus the smaller. So 128 minus 121.9 basically, and you get 6.1090. Now on my calculator, I didn't ever round. I took the exact number and I used the memory of the calculator to do that. So here we're rounding to the nearest cent. So if you think of these as, dollars and cents, then we need two decimals. So this is 6.11, and 6.11 is the correct answer to number 38. So thanks so much for listening to our solutions for test 1, section 4. And if you're ready to start tutoring with Gradeful, go ahead and reach out to us, and we'd be more than happy to set you up with a tutor and get you going toward pursuing your college dreams. Thanks so much.